Okay, so for this video, we are going to discuss the solution for the statistics paper for February March 2017 session. Okay, which is the paper 6 statistics 1. Right. Okay, so for the first question here, generally you can see that they want you to find out the mean and standard deviation for x minus 1760, and they already give you the original value of x. So there are 12 values of x shown below, so all these are the x. And since they want you to get the mean and standard deviation for the x minus 1760, therefore you actually need to minus every single value of x here with 1760. So as an example, the first x is 1761.6, you minus 1760 and you'll get 1.6. All right. Okay, so to calculate the mean, of course, you need the summation. So I will write out the summation here. To get the summation of x minus 1760. So generally, you have to do every single value here to minus 1760 from every single value here. So that means the first value minus 1760, you'll get 1.6. And then for the second value, if you minus 1760, you'll get a negative value, which is negative 1.5. So you have to keep the negative value itself, okay, the negative sign itself, and you continue the rest of the step, the rest of the values of x. So I'll have 2.3, and then 1.4, and then negative 0.6, negative 0.9, 2.5, 1.9, 2.4, 1.9, 2.8, and also 1. So you just need to make sure that you didn't do any careless mistake here. And by pressing the calculator to get the summation of x minus 1760. So the summation should be 14.8. All right. So besides the x minus 1760 summation, okay, I also need to get the summation of x minus 1760 squared to calculate the standard deviation or the variance, okay, for this set of value, right? For this set of value for x minus 1760. Okay, so you generally do the same thing, but you just need to square all the values that you get just now, which is 1.6 squared, and so on. All right, so of course you can continue to square every single value, and you have 2.8 squared plus 1 squared. Therefore, the summation of x minus 1760 squared, if you didn't do any careless mistake, you'll get 41.3. Okay, then after that, when you want to get the mean, so to get the mean for this value, all right, so the formula that we use is x minus 1760 summation divided by n. Okay, so which is 14.8 divided by 12. And to the 3 significant figure, you should get 1.23 as the answer. Right? Okay, then for standard deviation, the formula that we are going to use for this standard deviation is summation of x minus 1760 squared divided by n minus the summation of x minus 1760 divided by n, and you square this. All right. Okay, so if you substitute the value, you'll get 41.3 divided by 12, then minus 14.8 divided by 12 square and square root. So I would suggest don't use, for this value here, don't use the 1.23, right? Because the 1.23 you already shorten the answer. So if can, you try to use the original values or maybe the fraction, okay, to keep the answer to the higher level of accuracy. Okay, right. So if you press calculator, then for this value itself, you should get the standard deviation, which is 1.39. Alright, so this is actually the mean and also the standard deviation for x minus 1760. Right? Okay, then next, for after this, they actually want you to calculate the mean and standard deviation for the original set of value x. Okay, so to get the original set of value x, the mean and standard deviation. Okay, so generally we learned the coding formula before, which is x minus 1760 divided by n. You need to add back the 1760. So according to the answer that we get just now, I will get 1.23, or if you want, you can just write it as the original value that you get just now, which is 14.8 divided by 12 and then plus 1760, and therefore you'll get 1761.23. Okay, and for the standard deviation, and you know that for standard deviation, right, no matter you want to find out the standard deviation for x or the standard deviation for x minus 1760, generally their values should be the same, because the shape, okay, the when you plot the points on the number line, you can see that um, the the distribution of this set of data will be the same as this one. All right, so in general, the standard deviation value should be the same also, which is 1.39. All right, so this is what we have for question number 1. Okay, so for question number 2, there's a bag contain 10 pink balloons, 9 yellow balloons, 12 green balloons, and also 9 white balloons. Then out of all these balloons, right, you want to select 7 balloons. So maybe you can highlight the word 7 balloons are selected. So selected to me is a keyword. All right, so when you see the word selected, means that you can consider to use the combination, okay, to calculate the number of arrangement later, or maybe the probability later. All right, and then another word will be without replacement. Okay, and they want you to find the probability that exactly 3 of them are green. Okay, so the word without replacement also is quite important, because this actually tells you that it is not belongs to binomial distribution. If with replacement, that means that this question you can consider to use the binomial distribution and solve it. All right, but because of this word without replacement, so we know that it does not belongs to binomial distribution. Okay, and we only want to focus on the number of green balloons. All right, so which means you have 12 green balloons here, right? Okay, and the rest we can consider them as other color lah. So the other color one, you need to know what are the total number of the other color balloon. So if you add all of them together, and you will see that it should be equals to 28. Okay, all right. So now you want to get 7 balloons in total, and exactly 3 of them are green. So what is the probability? So to get the probability, because of the word select, okay, so I try to use the combination method to solve it. All right, so out of the 12 green balloons, you want to select only 3 and multiply with the rest. So the rest will be the rest color lah. The rest of the color will be 28, and you want to choose 4 of them. All right, and divided by the total combination without any restriction. So overall, you are having 28 plus 12 balloons, right? So overall, you're having 40 balloons, and you want to choose 7 out of the 40. All right, so this is actually the this one is actually the number of ways without restrictions. Okay, and the top one is 3 green balloon and also 4 other colors balloon. All right, so by pressing calculator, then very easily you can get an answer. So for this question, the answer should be 0.242. All right, so now we continue to question number 3. Okay, so there are 10% of the population enjoy watching the drama, okay, on television. So using an approximation, okay, so I think approximation is one of the important keywords here. All right, so the approximation will be one of the important keywords to find the probability that out of 160 people chosen randomly, more than 17 people, so more than 17 people enjoy watching the drama on television. All right, so for this question itself, generally there are a few important keywords to tell you what is the distribution or what is the method that you can use. So the first one is this one, approximation. Okay, according to the syllabus, all right, so in our AS level, okay, for approximation part, we only have binomial to normal distribution. Okay, sorry, so this one should be normal distribution. All right, so that means originally it should be a binomial, and we are going to change it become normal distribution due to the reason that I think all the numbers, okay, all the conditions are fulfilled. Okay, all right, so this is the one of the important hint, right? This keyword is actually one of the important hint to tell me that okay, originally it should be a binomial and we want to change it become normal. All right, so another one is the keyword here. You see that we are having out of 160 people a larger number, and then we are looking for the probability that's a group of smaller number more than 17. This is a smaller number compared with 160. All right, and then enjoy watching the drama on television. So more than 17 people, something happened to them. So for this kind of structure of the question, it belongs to binomial distribution. All right, so if you want, you can write out like X is actually the number of people enjoy watching the drama on television, and X is binomial distributed originally where the n is 160 and also the p. So what is the percentage of the population enjoy watching the drama on television? So it should be 10%, which is 0.1. All right, and since they asked us to use the approximation, okay, so we will change it become normal distribution. Okay, so the first value here, okay, the first value, the first parameter in the normal distribution should be mean. So how to get the mean? So you should take 160 multiply with 0.1, which is n times p lah for binomial distribution, and therefore you get 16. All right, as the mean. Okay, the second parameter for normal distribution should be a variance. So how to get the variance? It should be NPQ, which means it should be 160 multiplied with 0.1 and multiply with 0.9. So the variance here will be 14.4. Okay, all right. So you already get the value in the part in the normal distribution already for the parameter in the normal distribution, so we can start answering the question. So first of all, they want you to calculate the probability for more than 17 people. So X more than 17. So the number of people more than 17. Okay, so binomial distribution is a discrete random variable. Sorry, binomial is a discrete random variable, and normal is actually the continuous random variable. Therefore, when you change from binomial to continuous random variable, you need to do continuity correction. So for the continuity correction, okay, so for this question itself, it should be more than 17.5. You should add 0.5 here. All right. Then after that, we want to use the normal distribution table, okay, the normal table to find the probability. Therefore, you need to standardize it. So to standardize it, you have to take the original value of X minus the mean divided by standard deviation. So square root 14.4. All right, so from here you'll get a value for the Z. Okay, so the standardized value for Z will be 0.395. Okay, so if you want, you can draw a graph to show, right, which is the area that you want to find out. And we need to find out the probability from the normal table. Okay, and I know that for the normal table, okay, for the normal table, generally they only give you the area or the probability which is less than. Alright, so to get the more than, to get the more than value, you have to take 1 minus the probability for less than 0.395. So how are you looking for 0.395 here? Okay, so you look at 0.3 and you look at 9. So 0.39 will be this value itself. Okay, and then 5. So for the 5, you need to add what value? You need to add 19. So which means you have to take 6517 plus 19 and see what's the value that you get. Okay, so for this case, you get 6536. All right, so which means you have to take 1 minus 0.6536. and therefore the final answer that you get should be 0.346. I have changed it become three significant figure. All right, so this is the answer for question number 3. Okay, so for question number 4, right, so they give you the weight in kilograms, okay, for the packets of cereal, right, and then they were noted for 4 significant figures, and then these are the stem and leaf diagram. Right, so first of all, what they want you to do is that they want you to draw a box and whisker plot. Okay, so to draw the box and whisker plot, you need the 5 number summary, right? So you need minimum, Q1, Q2, Q3, and maximum. Okay, so before we start, you need to find all these 5 values first. Okay, so the minimum value and maximum value should be quite easy. So this is the minimum and this is the maximum. All right, so to find out the first quartile, second quartile, and also the third quartile, generally you need to calculate how many values do you have here in total. So you need to total up all these values. All right, so if you total all of them up, you have 59 data. Okay, so you can try to consider and see if you have a list of 59 data, right, which is the location, the center location of this set of data. All right, so if I have 59, which means that in front you should have 29 data, and the 30th data will be in the center, and after that you have another 29 data after the 30th, correct or not? So that you have 29. Okay, so that you have 29 plus 1 data here, plus another 29, and therefore you get 59. So which means that the 30th value here, will be actually the median, okay, for this set of data. All right, okay, so median means the center location, right? Okay, so maybe I rewrite this again. Okay, so which means the first part of the data, I'm having 29 value, and after that I have one value, then followed by the other one, which is 29. Okay, so this is one value here, so this one value here will be the 30th value. Okay, so this is actually the median. All right, okay, so to get the median, you need to look for the 30th data in this set of from this stem and leaf diagram. Okay, so the first row you're having 1, second row you're having 6, so you have 7 in total, 7 plus 12. So 7 plus 12 you get 19, okay, and you want the 30th. So after 19 will be 20, 21st, 22nd, 23rd, 24th, 25th, 26th, 27th, 28th, 29th, and 30th. This is the 30th number, and it also means that this is actually the median. All right, so from here I can write out first. So my minimum value is actually 0.7473 kilo. All right, and the Q2 or median is actually 0.7507, and the maximum is actually the largest value, 0.7532. Okay, then now I need to get the Q1, the lower quartile or the first quartile, and also the Q3, which is the upper quartile or the third quartile. Right? Okay, so now come back to our calculation just now. Okay, so for the median, right, we are having this exact value as the median, this exact data as the median. So to get the Q1 or Q3, right, you ignore this value. Okay, so you only focus on the first 29 values, the first 29 data. Okay, so for the first 29 data, right, I want to get the center location of this 29 data. All right, so how can I separate it and get the center location? Okay, so for 29 data, you can imagine, all right, the first, you can separate it become 14 in front, then you have one value in the center, and after that you should have another 14 at the back, so that 14 plus 1 plus 14, total they are 29. Okay, which means that this one value here will be actually the center location of the first 29 data. So this center location is actually the 15th value. All right, then the same thing happened at the end, at the second part of the value here. Okay, so you should consider actually also the same, which is you are having 14 value, then 1, and after that 14. So which means that this 15th value for the second part of the data will be the Q3. So this will be the Q1 and this will be the Q3. Okay, so Q1 will be the 15th data, right? So you count. So the first two row, you're having 7 values already. Then this is 8, 9, 10, 11, 12, 13, 14, 15. So the 15 value here will be 0.7495, which is your Q1. All right, and if you want to count the Q3, okay, so after the median, you count the 15th value, okay, after the Q3, sorry, after the median. So which means that you have to calculate from this value, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this 15 is the center, okay, of the second part of the 39 value. So this value itself will be your Q3. So I will write down the value which is 0.7517. Okay, right. So this is what we call as the 5-number summary: minimum, Q1, Q2, Q3, and maximum. All right. So after you list out all the values already, then you can try to draw the box and whisker plot. Okay, so we are having the smallest value, which is 0.7473, and the largest value will be 7532. Okay, so in general, maybe this is what we can have. All right, so we need to draw the ratio first correctly. Okay, so this one is 0.747. Okay, 748, 9, 10. Okay, so maybe you can make it like this, 0.748, 0.749, 0.750, 0.751, 0.752, and also 0.753, 0.754. So you draw out the ratio and also you try to label the x-axis. So this is actually the weight of the weight in kilogram. You can just write it in a simple way. All right, so this is the weight in kilogram. All right, so now the minimum value will be 7473. Okay, so 7473 will be maybe this one, will be here. All right, and after that Q1. So Q1 is 7495. So 7495, I think it should be this line. Okay, 7507 will be here. Okay, then 7517 should be around here. Okay, so this is Q1, Q2, Q3, the three lines here, Q1, Q2, and Q3. So these three values here will meet up as a box later. All right, and also the maximum will be 532. So 737532 is here. Okay, all right. So for Q1, Q2, and Q3, right, I will make it as a box. So this is what we call as a box. And then the whisker, you join from the box, go to the minimum value. And also you join it from the box to the maximum value. So this is what we have for our box and whisker plot. All right, so don't forget to label the x-axis. All right, okay. Then now for part number 2, they want you to name a distribution. So distribution means that is it looks like binomial, normal, or Poisson, or anything that we learned before. That might be a suitable model for the weights, okay, of this type of cereal packet, and justify your answer. All right, so for weights, right? Usually for weights, the distribution that we can use is usually normal distribution. All right, okay, so weights we measure it, correct or not? So it might be a normal distribution, and if you want to justify your answer, then you can look at the box and whisker plot that you draw just now. So you can look at the box. Okay, so for the box here, you can see that the distance, okay, the distance, right, from Q1 to median and also from median to Q3, right, they are more or less it is not exactly the same, I understand, but they are more or less quite same, the length, okay, the distance. All right, okay, so we can say that it is quite symmetric, right? So what is the reason that can justify our answer? Like, so you can say that the box, okay, that we draw, box and whisker plot that we draw looks symmetric. Okay, so this is actually the answer for distribution, and the second one is given for the justification. So you can just call it as symmetry, right? So this is what we have for question number 4. Okay, so we come to question number 5. All right, so for question number 5, there's a plate of cakes, hold 12 different cakes. So the keyword will be different. That means although they are all cakes, but they are all different one. Okay, so they are not identical, which means so the different will be a keyword. Okay, find the number of ways that this cake can be shared between Alex and James if each receive an odd number of cakes. Okay, so they want to share between two person, okay, two people. All right, so they are all different, which means they are not identical, but you want to separate it into to be shared for two people, right? Generally you can do combination. That means I want to know how many combination can be how many combination are there. All right, so that I can separate them, separate all the cakes into for two person, and the condition is each person must have odd number of cakes. All right, so maybe at first you need to try to figure out first. Okay, so let's say you're having Alex and also James. Okay, all right, and they are looking for the odd number of cakes, right? Okay, so maybe I start from a small number. Let's say Alex have one cake and then James have 11. So 11 plus 1 in total become 12. Okay, then maybe for the second case here, maybe Alex get 3 and James get 9. So 9 plus 3 is also 12. And the next case, maybe I'm having 5 and 7. Okay, then the fourth one will be 7 and 5. All right, and then fifth case is what? 9, 3, and the sixth will be 11 and 1. So there are 6 different cases here. Okay, but you can see that the numbers are repeated, okay, from here 7 5 9 3 11 1. So some solution might want to save the space, and then what they can do is like they just consider that this one multiply with 2 lah, because you can exchange the value. All right, but for me I will just write out everything. I will list out everything. So let's say we are having all the 6 cases here. Okay, so for the first case, for the first case here, I'm having Alex with 10 and also James 11. All right, so which means you want to select only one cake out of 12 and give it to Alex. And the remaining is 11, right? So you can write 11 C11. The remaining 11 will belongs to James. And you can see that for this 11 C11, right, the answer will be 1. Therefore, most of the time we are not going to write out this one. So the answer will be 12C1 for the first case. Okay, so the first case will be 12. All right, and then how about for the second case here? So for the second case here will be 12C3, then 9C9. Okay, so you're having 220 for this case. Then for the third case here, you can write as 12C5 multiply with 7C7. All right, so if you press the answer for 12C5, then what is the answer that you have? You should have 792. Okay, then for the fourth case is 12C7. Actually, the answer for 12C7 and 12C5 should be the same. All right, so you are having 792. So that's why there are some solution they will take 792 multiply with 2 straight away because they consider 5, 7 and 7, 5. All right, but for me here, I'm writing out the full steps. Okay, then for case number 5, you have 12C9. So again, 12C9 and 12C3 will be having the same answer, which is 220. And after that, the last case will be 12C11. So the 12C11 and 12C1 will be having the same answer also. Okay, so for this one, which is 12. All right, so the total number of ways means that you just total all of them up. Okay, so you are having 2048 ways. All right, so this is what we have for part number 1. Okay, all right, then now we continue to part number 2. So part number 2, they said there's another plate hold 7 cupcakes, and again different color icing. So that means they are not identical. All right, 7 cupcakes and then 4 brownies with different size. So all these are identical. All right, sorry, all these are not identical. So find the number of different ways that these 11 cakes can be arranged. All right, so maybe for me, arrange is an important word. Right, so arrange means that you have to consider the permutation for the calculation of answer later, or maybe you can try to consider the factorial. All right, all the factorial or permutation when you see the keyword arrange. Right, in a row, if no brownies is next to another brownie, so that means you're having 4 brownies, right, and all of them must be separated. Okay, so if let's say you want to separate all the 4 brownies, at first you have to arrange the 7 cupcakes first. So to arrange 7 different cupcakes, it will be 7 factorial, or you can write as 7p7 if you want. All right, so you are arranging all the 7 different cupcakes first. So after you arrange the cupcakes already, right? So you're having cupcake A, B, C, D, E, F, G. Okay, then you want to slot in the 4 brownies between the 7 cupcakes. So how many space you can slot in? 4. So you're having 1 space, 2, 3, 4, 5, 6, 7, 8. So you're having 8 spaces to slot in 4 brownies, which means that you are having 8p4. Okay, or you can write it as 7 factorial, and because you're having 4 brownies, right, so you can write in the 4 place first, 4 numbers or 4 slots. Okay, so uh, the first brownies you are having only one, sorry, the first brownie you're having 8 different spaces can be put in 1, 2, 3, 4, 5, 6, 7, 8 for the first brownies. If let's say you put in the brownies here, okay, so that means you have to delete this space already. Okay, so for the second brownies, you are having 7 remaining space. So let's say you put in the second brownie here, so which means this space is no longer available. So you still have only 6 spaces, okay, that you can slot in the brownie. So 6 and 5. So no matter which method are you using here, the answer that you get is the same, which is 8, 7, 6, 7, oh sorry, 8, 4, 6, 7, 2, 0, 0. Okay, so both will give you the same answer. This is what we have for second part. All right. Okay, so let's continue to the third part. Okay, so for the third part, now they are saying that a plate of biscuits hold 4 identical. So highlight the word identical. So which means that they are all the same. So 6 identical shortbread and also gingerbread, 2 identical gingerbread biscuits. And then these biscuits are placed in a row. Found how many different arrangements. So again, highlight the word arrangement. So when you see this word means that you have to use the permutation, okay, to do the calculation later. All right, arrangement means that you have to use permutation or you have to use the factorial, okay, concept to calculate the answer. Are possible if the chocolate biscuits are all kept together. Alright, so they want to keep all the chocolate biscuits together, which means that you have chocolate number 1, chocolate number 2, chocolate number 3, chocolate number 4. And they have to kept together, right? So you assume that they are tied up together. Okay, so this is only one item. You consider them as one item only. And then you are having 6 shortbreads and also 2 gingerbread. All right, so now because all the chocolate biscuits you want to keep them together, so you treat it as one unit only. So this one is one unit only plus 6 shortbreads and also 2 gingerbread. So that means in total you want to arrange 9 items. Okay, but out of these 9 items, right, there are 6 items here. They are identical. Therefore, you have to divide it by 6 factorial. And also these 2 items are identical. Therefore, you have to divide it by 2 factorial. Okay, so you no need to divide it by 4 factorial because for all these chocolate biscuits, right, the 4 chocolate biscuits, we assume that it is only one item. So when you calculate, you should assume that it is only one item, so it cannot be repeated. So you no need to divide it by 4 factorial. So the 6 factorial here actually comes from the 6 identical shortbread, and the 2 factorial here comes from 2 identical gingerbread. All right, so after this, you should get the answer 252. Right, so this is what we have for question number 5. Okay, so continue with question number 6. All right, so for question number 6, you can see that there's a pack A consists of 10 cards, and then all these are the numbers of the card, right? And then yeah, all these are the numbers of the card, right? The value of the cards, and then you are having pack B with 6 cards also, and then you're having 2 numbers here, so you are having 0 and 2, and then 1 card is chosen at random from each pack. So you're having A and B, right? So you want to select 1 card from each pack, and then X is the sum of the 2 numbers on the card. All right, and then they want you to calculate the probability for X equals to 2 and prove that the value is 2 over 15. Okay, so for this question, right, because I know that I'm taking out 1 card from each of the pack, and in total I'm having 2 packs here, and then to show all the possible results that I have, generally I will use a possibility space diagram. Okay, so you can use other method like some common sense to list out all the possible outcome also can during the calculation later, right? But for me, I will just show everything by using the possibility space diagram. Okay, so for pack A, I'm having 0, and the probability of getting 0 is 2 over 10 because you're having 2 0 out of the 10 cards, right? Okay, and after that, I'm having 1. So for 1, I have 5 over 10, the probability lah. So the bracket actually denotes the probability of getting the card number 1, and also the 3 here, I'm having 3 out of 10. Okay, and then for the pack B, I'm having 2 values only now, which is 0 and also the 2. Okay, so to get the 0, it should be 2 over 6, and then to get the 2, you should have 4 over 6. So the values in the bracket are all the probabilities. Okay, so for this one, the random variable x, it is actually the sum of the 2 numbers. So which means in all the cells here in this table, I am going to fill in the sum for 2 points, the 2 values. So as an example, like this one, the first value here is 0, and this one is also 0, right? So the total, the sum for these 2 values, 0 and 0 here, I will write in this cell, which is 0 as well. Okay, and after that, for this cell, all right, so I'm having 0 and 2. So 0 plus 2, it is equals to 2 for this cell. If you want to calculate the probability, also can. All right, so you can calculate them if you want, but for me, I will just leave it blank first. Okay, then for this cell, I'm having 1 plus 0, and therefore you get a 1 here. Then 1 plus 2, you get a 3 at the bottom. And then 3 plus 0, you get a 3. And after that, 3 plus 2, you get a 5. All right, so all these are the possible outcome that we have for the value of x. Okay, so for value of x, you're having 0, 1, 2, 3, and 5. And for first part, they actually want you to calculate the probability for x equals to 2 only. All right, so to calculate the probability for x equals to 2, all right, I'm going to look at this cell and how to get the 2. So you're having 4 over 6 multiplied with 2 over 10. All right, so to get the probability, you're having 2 over 10 multiplied with 4 over 6. So if you try to simplify it, you will see that the answer that you get is exactly 12 over 15, which is what they want us to show. Okay, so if you can get the correct answer for this part, which means that the method that you are using here is the correct method. So you can continue to use it in the next part. All right, if they want to calculate all the other probability. Okay, so we continue to part number 2. They want you to draw up the probability distribution table for x. All right, so I'm going to refer to this table now. Okay, so just now I already calculated the probability for x equals to 2. Okay, so I want to start with the probability for x equals to 0 now. So for 0, it is also very easy, which is 6 over 2 multiplied with 2 over 10. Alright, then you'll get the value here. Okay, so for this one, you should get the value 2 over 15, right? If I'm not mistaken. Oh, sorry, 1 over 15. Okay, alright, then the next one will be x equals to 1. Okay, so to get the probability for x equals to 1, you look at the probability that we get 5 over 10 multiplied with 6 over 2. So I'm having 2 over 6, sorry, 2 over 6 multiplied with 5 over 10. Alright, so for this probability, you get should be 5 over 30, is it? Oh, so when I simplify, I will get 1 over 6. Okay, then for the next one, x equals to 2. I already get the answer in part number 1. So I'm going to continue with x equals to 3. So to get x equals to 3, you will see that there are two parts, okay, two outcomes that you will get x equals to 3. Therefore, you should consider two cases here. The first case is 6 over 2 multiplied with 3 over 10. This is the first case plus the second case. So for the second case here will be 4 over 6 multiplied with 5 over 10. Alright, so if you try to simplify it, the answer for this one should be 13 over 30. Okay, and for the next one. Alright, so for the next one will be the probability of x equals to 5. Alright, which means this one. So to get x equals to 5, you have 3 over 10 multiplied with 4 over 6. So 4 over 6 multiplied with 3 over 10. And if you try to simplify it, this value should be 1 over 5. Okay, so after you've done all the calculation, then please draw out the probability distribution table. Alright, so I'm going to draw it out now. So draw it in a table form. Alright, then I'm having x and also the probability. So the value of x, there are 5, right? 0, 1, 2, 3, and also 5. Then for the second row of the table, you can put in all the probability. So for all the probability here, what you can put is 1 over 15 for x equals to 0 here. Okay, then for 1 is 1 over 6. For 2 is 2 over 15. And then for 3 is 13 over 30. And the last one will be 1 over 5. Okay, so this is what we have for the probability distribution. Alright, so usually for me, I will just try to double check again by adding up all the p-value here. Okay, the probability here, I will try to add all of them and see whether is it equals to 1 or not. If let's say it is not equals to 1, the total is not equals to 1, okay, which means there's something wrong in your calculation just now for the probability. But if let's say you get the total is equals to 1, that means you are having a high chance of getting the correct answer. Okay, so this is what we have for part number 2 by draw up the probability distribution for x. Okay, then if we continue to part number 3, okay, so for question number 3, they want you to calculate the probability. Okay, so highlight the word given that. Okay, so the word given that tells you that this is a conditional probability. This is a keyword. Okay, so given that x equals to 3, find the probability that the card chosen from pack A is a 1. So when I want to write out the symbol, okay, given that, that means I already know that x is equals to 3, the total for 2 cards. So I will write it here. Okay, so x equals to 3. And they want to find the probability that the card chosen from A is a 1. So maybe for the left hand side here, I'll write it as A equals to 1. Okay, so this is a conditional probability formula symbol, and I want to write out as formula. So when I'm having A equals to 1, divided intersect with x equals to 3, okay, then divided by the probability of x equals to 3. Okay, so now if we have a look, the probability of x equals to 3, you can straight away get it from here in the table, which is 13 over 30. Okay, and then for this one, when A equals to 1, intersect with x equals to 3 means that the total is 3, the total for the 2 card is 3, but at the same time, the card from pack A is a 1. So you need to refer back a little bit for our first part just now. Okay, so for our first part just now, if you look at it, okay, so the total is 3, right? So total is 3 means that you're having 2 cases here. First one and also the second one. But they want you to get the outcome where the pack A, the card from pack A is a 1. So you can see that this is 1, right, from pack A. Okay, so which means this is the case that you want to consider. This one. Alright, so to consider this case, what is the probability that A is equals to 1 and the total is equals to 3? So 5 over 10 multiply with 4 over 6. So in your calculation here, you can write, okay, 5 over 10 multiply with 4 over 6. Alright, so if you continue the calculation from here, okay, you should be able to get the answer, which is 10 over 30. So I will keep this as in a fraction form. Alright, so this is how we get the question number 6. Okay, so now we come to question number 7. Alright, so if you look at the question, they are talking about the length in centimeter of middle fingers of women in a country, right? Okay, so I have a normal distribution. Okay, so highlight the word normal distribution. So this is a keyword. Alright, so you are sure that you will be sure that this is a normal distribution question, and you need to solve it by using all the normal table and everything. Right, so they didn't tell you the mean and also the standard deviation. Okay, but they give you some extra information here. So saying that 25% of these women have fingers longer than 8.8 cm, and also 75% have fingers shorter than 7.7 cm. So by using these two information, they will want you to find the value for mean and also the standard deviation. Right. Okay, so from the information that they give us, the first one is more than 8.8 cm, longer than 8.8 cm, the probability is 0.25, the 25%. Okay, all right, so now you need to use this information to create one equation that consists of mu and sigma. Right, so from x, you want to change it become z, standardize it. So 8.8 minus the mean divided by standard deviation for normal distribution, and it is equals to 0.25. Okay, so from here, if you try to draw a graph, okay, the normal graph, you can try to figure out and see actually how your graph will look like and what is the value for z. Okay, so 0.25, and you see the greater here, right? Greater sign, and this is a small value, which means that your z should be somewhere here. So this is your z, which is 8.8 minus the mean divided by standard deviation. And they say greater than this value. So greater than this value means this area, and this area is a small area, which is a 0.25. Okay, so this is how my graph look like. All right, and by using this graph and also the normal distribution table, I want to find out the value for this z. Okay, so how to find out this value here? So 8.8 minus the mu divided by sigma. Okay, it is equals to, you have to look at the 0.25. So this is the probability, right? If you want to get the value for probability, all these are probability. So you should look from here and get the value outside. Okay, but if you look at all the table, the whole table here, you don't have any value which is smaller than 0.5. 0.25 is smaller than 0.5, right? So you won't able to get 0.25 from all this area here. Okay, so what you need to do now is you have to take 1 minus if you face this case. All right. Okay, so for this one, instead of using the 0.25, all right, so I will actually try to find out the value for 1 minus 0.25, which is 0.75. All right, so instead of 0.25, I'll look for 0.75. Okay, so if you look at the table here, you have to look at the value inside. Okay, because all these are probability value. So the value inside here, okay, sorry, wait me for a while. Okay, so 0.75. Okay, 0.75, what I can see is this value is closest to 0.75. Okay, so the z value, if you look out, it will be 0.67. But to get the 0.75, right, you need to add 14 for this value, or 0.0014 lah. Okay, so if you want to add 0.0014, there's no 14 at the end, but you have only 13. So we choose the closest value to 14 to 14, which is the 13. So the value for it will be 4. Okay, so from the table you can see that it is 0.674. All right, then you can put in the value 0.674. So from the graph that you draw just now, because you can see that this value itself is actually on the right hand side of 0. 0 is in the middle, right, in the center. So this value is on the right hand side of 0, which means that this value is a positive value. Therefore, the 0.674 will be a positive value. Okay, 0.674 will be positive. All right. Okay, so this is one of the way that you found the 0.674. Another way is if you know that there's a smaller normal table, okay, a shortcut normal table at the very bottom part of the formula booklet, then you can have a shortcut here. So you are still looking for 0.75, right? So if you look for the probability, which is 0.75, and the value itself is 0.674, it is a more straightforward way lah. Okay, but too bad all these probability are limited. All right, they only give you a few important probability here only. So 0.75 is under this table. So you can see that the 674 is listed out, okay, in a more straightforward way. So you can also straight away use this small table to get the 0.674. Okay, so after you get the 0.674, so you can rephrase this equation and you can get mu equals to 8.8 minus 0.674 sigma. All right, and I will make this as the first equation. Okay, all right. So I already have my first equation with mu and also the sigma. All right, then now I'm going to get the second equation. So to get the second equation, all right, so I need to use the second information. So the second information is 17.5% have fingers shorter than 7.7 cm. So if I want to write out into a symbol form, it will be the length of finger less than or shorter than 7.7 cm. The probability is equal to 0.175. Okay, so the same thing happened. This is a normal distribution. Therefore, you need to change it become Z by standardizing it. So 7.7 minus the mean divided by standard deviation, and you get 0.175. All right. Okay. Then now, I want to find out the Z value. So maybe before that, I try to sketch the graph first for the normal graph. The 0 is in the center. All right, and then if you look at the area, this area is a small area lah. Just 175 is a small one. More than 0.5 is a large one, right? So this is a small value, small area, sorry. And then you can see the sign here. This sign is smaller than. So that means the graph that fulfill what we have here is this one. So which means that this is your Z value, 7.7 minus the mean divided by standard deviation. And the area smaller than this value, smaller, right? Smaller than this value is this area. And also from here, this area, you should know that it is 0.175. Okay, so now I want to find out the value for this one. Okay, so what's the Z value? So 7.7 minus the mu divided by standard deviation equals to a value. So I want to find this value now. Right, so the same thing happened like what we get just now. Okay, so you should look for the area 0.175. So again, if you look for all the values inside here, there's no 0.175. So the same method that we do is, instead of using 0.175, what you can do now is you can try to use 1 minus 0.175 and see what's the value that you get. All right, so from here you should get 825, 0.825. Okay, All right, so now I'm looking for 0.825 from this table. All right, this table. Okay, where is 825? So if looking for 825, I will see that this is the closest value to 825. Okay, so if you look up for the value here, it will be 0.93. Okay, but to get 825, you need to add 12, right? At 0.0012 to get 825. So let's have a look. Where is 0.0012? The 12. There's no 12, but the closest value will be 13. Okay, so I will look for this one, and you can see that it is 5. Okay, so end up you have what value? 0.935. Okay, so for my steps here, I write out as 0.935. But according to the graph that I draw just now, you will see that this value itself is on the left-hand side of 0. Left-hand side of 0, which means that this whole value should be a negative value. So the answer that I get should be a negative 0.935. Okay, so continue from this part. If you want to build an equation with mean and also the sigma, the equation will look something like this: 7.7 plus 0.935 sigma, and this is the second equation. All right, okay, so now very clearly you can see that you have two equations. You form two equations from the information given. So to get the value for mean and also the standard deviation, you need to solve these two by using simultaneous equation. All right, so you can let 1 equals to 2. Okay, so which means that you're having 8.8 minus 0.674 sigma equals to 7 plus 7, 7.7 plus 0.935 sigma. Okay, so if you continue carefully from this step, right, so you should get 1.609 sigma equals to 1.1, and eventually your sigma should be equals to 0.684. Okay, all right, so this is what we have for the sigma. And once you get a sigma, of course you can get the mu easily. So to get the mu, you can use any of the equation that you built just now. So 7.7 plus 0.935 sigma. Okay, so try to get and see whether the answer is 8.34 or not. All right, so this is how we get the value for sigma and also how we get the value for the mu. Okay, so continue with 7a part number 2. Right, so now for this question, they mentioned that the length in centimeter, okay, for another country or another place has a normal distribution again. So highlight the keyword normal distribution with this mean and also this standard deviation. So a random sample of 5 women from this land, okay, snow land is chosen. So find the probability that exactly 3 of these women have middle finger shorter than 8.2. Okay, so now for this question itself, I don't know whether you can see it clearly or not. Of course, you have a normal distribution for the length of the fingers, okay, for women. And after that, for the calculation of probability, they are talking about in total you're having 5 women and exactly 3 of them something happened. So when you see this kind of structure, it is actually the binomial distribution, right? Okay, but you have to try to link the normal distribution with the binomial distribution here. Okay, so maybe for normal distribution, maybe the x, I will make it as the length for the fingers of the women. Okay, and then maybe for the y, all right, so I will maybe label it as the number of women. Number of women, if you want it to be exact, then it should be the number of women that has or have the middle fingers, okay, shorter than 8.2. Okay, so from here you can see that the shorter than 8.2 is actually related to the length. Alright, so maybe before we can start with the binomial distribution calculation, you should try to calculate the probability for the length, which is smaller than 8.2 first. Okay, so to calculate the length, which is smaller than 8.2, you need to standardize it. So 8.2 minus the mean, which is 7.9, divided by standard deviation 0.44. Okay, and from here you get the z value, which is 0.682, right? 682. Okay, so to get the probability for 0.682, you look at 0.6 and 8. Okay, so 6, 8 means you get 7,517 plus 2. Okay, with 2. So you need to plus the 7 here. So which means 7,517 plus 7. And from here you get 7,524. Therefore, the answer for this will be 0.7524. Okay, so this is a probability. And now you want to substitute it into the binomial distribution. I'm having 5 women. The probability that a woman has the finger length less than 8.2 is 0.7524. So the 7524 is actually something like the P, okay, in the binomial distribution parameter, the P, okay. All right, then you want to calculate the probability for y equals to 3, exactly 3 so y equals to 3, so it should be 5c3 p power 3 and q. How to get the q? So you take 1 minus 0.7524. If you take 1 minus this value, you'll get 0.2476. So this is your q power 2. So end up, you correct it into 3 significant figure, the answer should be 0.261. So this is how we get part number 2. Okay, the answer for part number 2. Okay, then now let us continue further for the next part. Okay, part B, question 7, part B. All right, so now for part B, if you look at the detail, okay, the random variable x has normal distribution. So again, I highlight the word normal distribution. Mean equal to the standard deviation. So when I mention mean equals to the standard deviation, means the mean is equals to standard deviation, right? Okay, find the probability that a particular value of x is less than 1.5 times the mean. So for this case, they want you to find out the probability that x is smaller than 1.5 times of the mean. Mean means mu. Okay, so how to calculate this probability? Because it is normal distributed, so you need to change it become z. 1.5 mu, I will change become 1.5 sigma. Okay, or maybe if you don't want, you can just keep it as mu, also no problem. Up to you, alright? So maybe if you want, you can keep it as 1.5 mu minus the mean. Standardized, so minus the mean divided by standard deviation, so divided by standard deviation. Okay, so if you continue from here, then you can see that z is smaller than 0.5 mu divided by sigma. And since just now they already tell you that mu is actually equals to sigma, right? So you can change the mu become sigma. So sigma divided by sigma, you can simplify them. And therefore you get z smaller than 0.5. So how to find the probability for z smaller than 0.5, which is very simple. You just look at 0.50. So the value that you get for this one is 0.6915, and change it become 3 significant figure, you will get 0.692. So this is what we have for the part 7 part B.